we'll be taking a look into the chapter mathematical logic. So firstly, we'll be taking a look into level 1 sums, which are easy type. So now the question is, if P is square of any real number is positive, this is statement P. Statement Q is 5 plus 4 equals 11. And statement R is square of any odd number is even. So which of the following has a truth value T? So we have to find which among these statements has a truth value. So first we'll take a look into P. So a real number can be positive, negative or 0. So we know that square of a negative number is always positive and square of a positive number is positive. But square of 0 is 0. So it is neither positive or non-negative. So this statement does not hold true for 0. Hence this statement is not always true. So we cannot say P is true. Now for Q, this is 5 plus 4 equals 11. So but 5 plus 4 is 9. So Q is false. So this is false. Now let's check R. R is square of any odd number is even. Take an example of 3. 3 is an odd number. Square of 3 is 9. So square of an odd number is odd, and it is not even. So R is also false. So the only option which is left is D, which is negation of P and negation of Q and negation of R. So let's verify it. So we can write this as P has a truth value of false since it is not always true. So this can be written as negative F, and Q is also false. So this is also negation F, and R is also false. So this is negation F. So negation F is true. So this is T and T and T, which is the same as T. So option D holds true value. So the next question is, if statement P is every natural number is a whole number, Q is equation x square minus 3x plus 2 equals 0, has two real roots, R equals 1 is a prime number, which of them is truth? Which of them has a truth value of F? That is, which of them is false? So we have to find the false statement among these. So let us check. P is every natural number is a whole number. Now whole number is 0 to infinity and natural number is 1 to infinity. So we can say every natural number is a whole number since it also includes 1 to infinity. So P is true. So P is excluded. So option A is not the right answer. Q. Now Q is x square minus x plus 2 equals x square minus 3x plus 2 equals 0. So if we want to check if the roots are real, we'll see if b square minus 4ac is greater than 0. So in this case, b is minus 3, a is 1 and c is 2. So b square minus 4ac is the square of b is minus 3 square, which is 9, minus 4 times ac, that is 4 into 2 into 1. So this is root of 9 minus 8, which is equal to root 1, which is 1. So 1 is real. Therefore, we can say the roots are real. Both the roots are real. So Q is also true. So now R is 1 is a prime number. So, but R is neither a prime nor a composite number. So 1 is not considered a prime number. Therefore, R is 1 is false. So the answer is C, R, which is false. Next question is, statement P is Mumbai is the capital of India. Q is x square minus 5x plus 6 equals 0 when x equals 2. And statement R is 829 is divisible by 9. So we have to find the statement which has a truth value of T, that is true. So first let's check P. P is obviously false since capital of India is Delhi. So let's check Q. X square minus 5x plus 6 equals 0 when x equals 2. So let's put the value of x as 2. So this is x square, that is 2 square which is 4, minus 5 into 2 which is 10, plus 6 equals 0. That is 4 minus 10 plus 6 equals, let this be unknown. So this is equal to 0. So this matches the RHS. So we can say this equation satisfies the value of x as 2. So Q is 2. So B is the answer. Let's also check R. 829 is divisible by 9. So 829. So let's divide by standard procedure. So 89 into 9 is 81. 1 is carry forward. So now the remainder is 19, but the multiple of 9 is 18. So 829 is not divisible by 9. So R is false. So the only statement which holds true is B, Q. That is x square minus 5x plus 6 equals 0 when x equals 2. Next question is, if statement P is sin theta is equal to 2 sin theta cos theta, where theta is a mango. This is statement P. Statement Q is sin 2 theta is 2 sin theta cos theta for all theta. Statement R is 2 sin 2 theta is 2 sin theta cos theta for all real values of theta. So which of them is not a statement? A statement is which is specific. So let's check P. So P is sin theta is equal to 2 sin theta cos theta, where theta is a mango. Even though this is false, but it is specific. It is specifying the value of theta, which is a mango, even though it is false. So P can be considered as a statement. Let's check Q. Q equals sin theta 2 theta minus 2 sin theta. 2 sin theta cos theta for all theta. Let's keep this aside for a while. R is sin 2 theta equals 2 sin theta cos theta for all real values of theta. So they have specified a domain for the value of theta, which is a real value. Real value, that is, it can be negative, positive or 0. So this can be considered a statement since they have specified the range of theta. So let's now check Q. Q is sin 2 theta equals 2 sin theta cos theta for all theta. Even though they have said all theta, it does not specify the range. Theta can be either a number or an alphabet or a fruit, anything. So they have not specified anything for theta. So hence this statement is vague. So we cannot call this a statement. It is an open sentence. So therefore B, Q is the answer, which is not a statement. So this is a comprehensive type of question. We'll be using two statements for the next 5 questions. So statement P is Rohit is tall. Statement Q is Rohit is handsome. We'll be using these two statements as a reference for the next 5 questions. So we have to find the symbolic form of the statement in the questions. So the statement is Rohit is tall and handsome. So we know that P is Rohit is tall. So negation of P is Rohit is not tall. Similarly, Q stands for Rohit is handsome. So negation of Q is Rohit is not handsome. So this is the statement is Rohit is tall and handsome. So Rohit is tall is P. The statement conjunction used is and. So symbol for and is this. So and Rohit is handsome is clubbed into the sentence. So this is Q. So the answer is P and Q, which is option B. Next statement is Rohit is tall but not handsome. So we know that P is Rohit is tall but not handsome. We can write this as Rohit is not handsome. We can write this as negation of Q, which is Rohit is not handsome. So we can rewrite this sentence as Rohit but is a conjunction. We can replace this as Rohit is tall and Rohit is not handsome. It means the same. So now we convert this sentence into a symbolic form. So this is P, Rohit is tall, and negation of Q, that is Rohit is not handsome, which is option C, P and negation Q. Next statement is Rohit is neither tall nor handsome. This can be written as Rohit is not tall and Rohit is not handsome. It means the same. This is a conjunction. This is a form of conjunction. So this is statement negation P. This is statement negation Q. Since this is a conjunction and, so we can write this as negation of P and negation of Q, which is option B. Next statement is Rohit is tall or he is short and handsome. So Rohit is tall is P. Rohit is short is synonymous to Rohit is not tall. So this can be written as negation of P, which is Rohit is not tall. Rohit is handsome is Q. So let's split the sentences. So first comes Rohit is tall, which is P. Or, so we use or. He is short. He is short, which he is short means negation of P. So this is negation of P and handsome. And handsome, which means and Q. We put a bracket to separate this term. So the answer is B, A, P or negation of P and Q. Next statement is, it is false that Rohit is short or handsome. So let us assume this statement is true. So it claims the statement is false. So this can be written as negation, since it is denying the fact that Rohit is short or handsome. So this is negation. We'll take this into a bracket. So Rohit is short or handsome. Rohit is short is P is Rohit is tall. Negation of P is Rohit is not tall, which is equivalent to Rohit is short. So this is negation P or. So or handsome, that is Rohit is handsome, which is Q. So using De Morgan's law, we can distribute the negation term. So this can be written as negation of negation P, negation of or is and negation Q. So negation of negation P is P, and we rewrite these terms. So P and negation Q, which is option C, P and negation Q. The next statement is, it is not true that Rohit is short or not handsome. Not true can be written as false. This is similar to the previous sum. It is denying the statement which is mentioned here. So we start with a negation and a bracket. Now this is made up of two sentences with a conjunction, that is or. So this is statement related to P and this is statement related to Q. So statement related to P is Rohit is short, but P is Rohit is tall. Rohit is short is equivalent to negation of P, as seen from the previous sum. And Rohit is not handsome is equivalent to negation Q, and it is combined by the combined by or statement. So we can write the inner part of the bracket as negation of P or negation of Q. Again, using De Morgan's law, we distribute the negation term. So we get negation of negation P, negation of and or is and. So this is and negation of negation Q. Negation of negation P and negation of negation Q is P and Q respectively. So the final answer is P and Q, which is option D. Now we'll see another comprehensive statements. This is similar to the previous set. The statement which we'll be using is P equals Sam is fat, Q is Sam is happy. So let P be Sam is fat. Negation of P is Sam is not fat. Not fat, which is equivalent to Sam is thin. Q is Sam is happy. So negation of Q is Sam is not happy or Sam is sad. So we have to convert this statement into symbolic form. Sam is thin but happy. This can be written as Sam is thin and Sam is happy. So Sam is thin is opposite of Sam is fat, which is negation of P. The conjunction used is and. So this is and Sam is happy is Q. So the answer is negation of P and Q, which is option D. Next statement is Sam is fat or unhappy. So P is Sam is fat. Negation of P is Sam is not fat or Sam is thin. Q is Sam is happy. Negation of Q is Sam is not happy. So the statement says Sam is fat or unhappy. So Sam is fat is statement P combined by or. So it is or. Sam is unhappy is negation of Q. That is. So the final statement is P or negation of Q, which is option B. Next statement is if Sam is fat, then he is happy. So P is, this statement is P, which states Sam is fat, and this statement states Sam is happy, which is Q, which says Sam is happy. So it is combined by conditional statement, which is if then. So this can be written as P arrow and Q. So P is a conditional value for Q. So the answer is C, this one. This condition is, this condition states if Sam is this is biconditional statement, that is these statements depend upon each other, that is neither of the statement will occur independently. So the answer is C, that is which states if P is to occur, that is if Sam is fat, then he is happy, that is Q will occur. So we have another comprehensive set. The two statements which we are going to use is P, it is cold, Q, it is raining. So let P be, it is cold, and Q be, it is raining. So we have to find the inverse, reverse of what we were doing previously. The symbol is given and we have to form a sentence using that symbol. So the symbol given is negation of P. So negation of P is, P means it is cold. So negation of P means it is not cold. So the answer is A, it isn't cold. This is a question. This is not a sentence. This is a question. So this is not a statement. This cannot be considered a statement. C is considered a statement because it is a sentence. So the answer is C, it is not cold. The next symbol is Q or negation P. Now P stands for it is raining. P stands for P stands for it is cold, and Q stands for it is raining. So the statement is Q or negation P. So Q is it is raining or negation of P. Negation of P is it is not it is cold. This is Q. It is cold or it is not raining. So rewriting this statement. So answer is it is cold or it is not raining. Sorry, there is a mistake. Statement P is it is cold. Statement Q is it is raining. So Q is it is raining or it is not cold. It is not cold is negation of P. So the answer is B. It is raining or it is not cold. Now the symbol is negation of P or negation of P. Negation of Q. P is it is cold and Q is it is raining. So negation of P is it is not cold. And negation of Q is it is not raining. The connector used is or. So we have to find a statement which uses these elements. So first we have to find it is not raining. So the options are it is not raining, it is here, nor raining. This cannot be included because it says it is raining. So there is another not raining. So option is either of these. So let's check B. When it is not raining, it is not also cold. Also not cold. So this is a conditional statement. So this is not valid. D is not valid. B is not valid. So let's compare A and C. It is neither raining nor neither cold nor raining. C is it is not cold or it is not raining. So the connector used is or, and in this statement it is neither cold nor raining. It is a form of and, negation of and. It means it is not cold and it is not raining. So the symbolic form of this is negation of P and negation of Q. So this is invalid since the connector here is or. So the answer is option C. It is not cold or it is not raining. So this is similar to the previous question. So it is negation of P and negation of Q. So negation of P is it is not cold since P was it is cold, and negation of Q is it is not raining. Let's check the options. So option A is it is neither cold nor raining. So this states that it is a form of and. It means it is not cold and it is not raining, which gives us the answer. So the option is A. It is neither cold nor raining. Now we are back to simple questions. So the question is which of the following is not a correct statement? So we have to find the statement which has truth value in it. So option A is mathematics is interesting. So this is an opinion. This is not even a statement. This is an open sentence. So this cannot be. This is either true or false. So this is not a statement. So this question option is invalid. Root 3 is prime. Now root 3 is not a whole number. So it cannot be prime. So this is false. This cannot be true. Root 3 is irrational, which is true. A sun is a star, which is also true. So the answer is B. Root 3 is a prime number. This is not a correct. This is not a correct statement. So we had to find the true statement which had a truth value of false. Now we are back to comprehensive questions. We'll be using the statement P and Q for the next 5 questions. Statement P is price increases. Let us denote this by the symbol. So price increases. Q is demand falls. Demand falls. So we have to find the symbolic form of the sentences which are given. So the given sentences: if price increases, then demand falls. This is a conditional statement which says when price increases, this leads to fall in demand. So P leads to Q. So this can be written in symbolic form as P arrow Q, which is option B. So it is a condition where P leads to Q. Next sentence is price increases if and only if demand falls. So let us recall the conditions statements. So P is price increases and Q is demand falls. So it says price increases if and only if demand falls. It says increase in price is the necessary and sufficient condition for falling of demand. So this is biconditional statement which is denoted by double arrow. So this statement can be represented as P biconditional Q. So the answer is A, P biconditional Q. Since this indicates biconditional statement, that is necessary and sufficient condition. So next statement is if demand does not fall, then price does not increase. Now we have P is price increases and Q is demand falls. So demand does not fall. This means negation of Q. This statement. And this statement means price does not increase, which is negation of P. And it is combined by using a conditional statement, that is if then. So negation of Q is a sufficient condition for negation of P. So this can be written as negation of PQ arrow negation of P, which is option C. The statement is if price does not increase, then demand does not fall. Now P is price increases and Q is demand falls. So statement 1 is price does not increase. So this is negation of P. Demand does not fall is negation of Q. So it is a conditional statement, if then. So this can be written as negation of P implies negation of Q. But now we can see there is not an option which matches with our answer. So now we'll use a concept known as contrapositive of a conditional statement. It states that P implies Q. The contrapositive of this statement is negation of Q implies negation of P, and these are equivalent. So this is the same as P implies Q is the same as negation of Q implies negation of P. So we'll find the contrapositive of this statement. So this is Q implies P. So our answer is B, Q implies P. So in this question, it is given that the truth value of P is F and for Q it is T. So we have to find out which of the statement has the correct truth value. So let us simplify each options one by one. So negation of P implies negation of Q, which is equivalent to P is false, so negation of false is true. So true implies negation of Q is a negation of T, which is false. So T implies false. So T implies false is the same as false since TF is F as per the truth table for conditional statements. So the option A is wrong since it is given it is true. Let's check option B. So P implies Q and P. That is false implies Q is true and F. That is equivalent to for AND condition both the values should be true, only then it will be true. So here it is false, so it is F implies F. So F implies F is true since only true implies F has a false value, otherwise it is true. So for conditional statement it is true, but it is given it is false. So option B is also wrong. Let's check C. So C is P and Q and P and negation Q. So this is equivalent to P is false, P is false and Q is true, and false and negation Q, that is false. False. Since Q is T, so negation Q is false. So false and true is false. Since TT, true and true is true, false and true is false, and false is also false. So this turns out is F and F, which is the same as F. So this is false, and in the option it is given the value is false. So C statement is right. So the answer is C, P and Q, and P and negation Q. Let P be any statement, then P and negation of P is a contingency, contradiction, tautology, or theorem. So first let us form a truth table for this statement. So let this be P and negation P. So let P have values true and false. So negation P will have false and true. So P and negation of P will be, so in this case, if both are true, then P and negation P will be true. So since both the terms are not true, so the value is false. T is T. So there is no two true terms. So the values are false and false. So since all the values in this table are false, it is a contradiction, since it is a table consisting of only false values. So the answer is B, contradiction. Now this is similar to the previous one. P is any statement. We have to find the type of statement for this symbol. So it is P or negation P. Let us draw the truth table again. So let P be true or false. Negation P will be false and true. So P or negation P is so condition for our statement is FF is F, everything else is true. So in this case there is no FF, so the values are true. So now contingency is a table consisting of both true as well as false. Contradiction is a statement consisting of only false values, and tautology is a statement consisting of only truth values, and paradox is a confusing statement and ambiguous. So since the table consists of only truth values, so the answer is C, tautology. Now we have to find the negation of the statement, negation of P or negation of Q. So solving this, negation of negation P or negation Q. By De Morgan's law, negation will be distributed in the bracket. So this will be negation of negation P, negation of or is and. So negation of negation Q. Negation of negation P is P, and negation of negation Q is Q. So this will be P and Q, which is option D. Now we have to find the negation of this statement. This is false or that is true. So now we'll split this big sentence into smaller statements. So let P be this is false, and Q be that is true. So symbolic form of this sentence will be P or Q. So negation of this statement will be using De Morgan's law. So this will be negation of P, negation of or is and, negation Q. So rewriting this in the form of a sentence, so this will be opposite of this is false is this is true. So this is true. Negation of that is true is that is false. this turns false and this becomes true in case of negation. So that is false. So option C is the answer. This is true and that is false. Now the negation of the statement, this is true and that is false is, so let P be, this is true, it is connected by and statement and conjunction, so this is and that is false is Q. So symbolic form of the given statement is P and Q. So negation of this statement is negation of bracket P and Q. Distributing negation, we get negation of P, negation of and is or negation of Q. So rewriting this in the form of a sentence, we get this is opposite of true is false. So this is false or that is true. So the answer is option D. This is false or that is true. Conditional P implies Q is equivalent to, the answer is option B. It is as per a formula. So P implies Q is the same as negation of P or Q. This is a formula. You are supposed to remember it. That's an extra fact. Similarly, negation of P implies Q will be negation of negation P or Q. So expanding the brackets using De Morgan's law, we get negation of negation P and negation Q, which is the same as P and negation Q. So in summary, we can say P implies Q is the same as negation of P or Q, and negation of P implies Q is the same as P and negation Q. So now we have to find the logical equivalent of negation of P and Q. Since all the options uses the implication condition, so we'll write the formula again. So as seen from the previous question, so this P implies Q is the same as negation of P or Q, and negation of P implies Q is, this is P and negation Q. So now we know P implies Q is the same as negation of P or Q, but here we are using and statement and condition, so this is not the option. Similarly, negation of P implies Q is P and negation Q. Here it is negation P and Q, so this is also wrong. So let's check just these two options. So Q implies P will be negation of Q. Here we have negation of the first term, so this is negation of Q or P, but this is not the same. We are using and it is negation of P, so this is also wrong. So the only option available is D. Let us check this also. So this is negation of Q implies P, so this will be Q and negation of second term, that is negation P. So this is the same as negation of P and Q, which is what we were asked. So D is the option, negation of Q implies P. So with this we are done with level 1 set of questions. In the next part we'll be dealing with level 2 set of questions, which will be slightly tougher than these type of sums.